I had to take a video down. Wasn't my choice. And so I'm going to replace it with this one. This is a drawing that I've made to guide us. Be sure to check the description for a link to download the drawing and this part so you can follow along or just have this part for reference. Let's get started by creating a new part, a new sketch, and choosing the XY plane. So from here, the origin placement is going to be arbitrary, but I'm going to put it right in the middle of this circle. And I know that this circle has a radius of 0.55 inches. So we'll grab a center and end point radius, or arc, 3-point arc. We'll say Shift R, and notice my keyboard monitor down here if you need to know where your hotkeys are. We're going to give this 0.55. Now we'll grab a regular line. You can use polyline too, but regular line seems to work pretty well. I'm going to choose these 3 points. We'll go with parallel. We'll go with perpendicular, and E for equal. And now I know that we have a line width of 0.35, so we'll grab this little angular distancer, and we're going to say 0.35 inches. I know that I want this and this line to be 0.77 inches away, so we'll go from the origin out to this line, 0.77. And then we need to establish an angle, and our angle is 120 degrees, so I'm going to hit the A key for angle, and we're going to say 120. And there we have a fully defined keyway. Let's again use a center and end point arc. We're going to go from here to here, and here to here. We're going to say T for tangent, and we're going to make this arc and these lines tangent, A for angle. And then I'll grab a, let's go with a 3-point arc. Those are visually quite nice. I can make these lines equal, like E for equal. We'll make this center point horizontal with the origin. We'll give this a radius with Shift R, and this outer radius is 1.89. Next, I have to know what my out to out is, right? And I can also actually stand to add a tangent relation there, and that will help me as well. I also should give the radius over here, right? This is a radius of 1 inch, so we'll say Shift R 1 inch. So now I have 1 degree of freedom. What's my out to out? And to figure that out, I know that my drawing is calling 9.75 inches overall length from one side to the other. And since when you dimension a radius, it goes to its center point, and I have to dimension an out to out, I'm going to add in some helper points. Here to here to here. H for horizontal. And now I can dimension off of these points. So we'll go horizontal and 9.75, and we're fully constrained, at least on the outside. Next, we're going to create a circle, and we have a diameter call out for the circle. It's 2.9 inches. So we'll give a Shift R, and we're going to say 2.9 divided by 2. You also can select a diameter, but I just leave it on radius and divide by 2 because it's easy to have one thing instead of switching between two tools. Purely personal preference. I'm going to go back to a center and end point radius, or arc, and grab these and these. And we're going to grab, this is a total of 6 arcs. I'm going to hit T for tangent and click on each arc to make sure that they are all tangent to one another. And then I'm going to get an E for equal constraint and make sure that every arc is equal to every other arc. And then let's draw a line from here to here, and here to here. Tangent, again, and I'll make sure that we're tangent to the line. Next, we'll choose a parallel relation, and we're going to go parallel to these walls. And now finally, I can say Shift R and give this a radius of 0.25 and start assigning dimensions. We know that this is going to be 1.9 and this is going to be a radius of 1 from the drawing. And then we're given this sort of 0.4 inch thickness. I think an easy way of doing that is to switch to construction geometry. And coming over here, we'll make that coincident. We'll give this a perpendicular relation and give this a thickness of 0.4. Next, if I just choose these points and say vertical, we will be fully constrained. So since that was our last degree of freedom, we can go ahead and close. Next, there's a few ways to do this. In the old video, I did it the very simple way and just created another sketch and extruded one, cut the other. Maybe I can demonstrate that for you in this video. But for now, let's try something a little bit more proper. I'm going to come over here. You can see in our history tree, we have a body and we have a sketch as a part of our body. Well, I can make another body right here, which I will do. So I click on that to create another body. And now I have two separate bodies in my part, and I'm going to make a sketch in the other body. And of course, we will sketch this other profile. Now I know that the origin is the very center of this circle, and this circle has a radius of 1 inch. So I can go an inch out. Let's see here. Got to go back to driving geometry, and I'll choose polyline. Alright, so I can go an inch out, Shift H, and know that I've accurately aligned this end with the end of this circle. There's a number of other ways to do it as well. Now you'll see that we're going to be doing a boolean operation, and there's a point at which these collide. That gives the potential of 0 thickness. The boolean will work, right? FreeCAD will let the boolean work, but it is better practice to go a little bit further out. And we can with our boolean because this edge will now determine where the part ends. So this could be any dimension over 1 inch, and the boolean will make sure that we go to the right spot. I'm going to go to E for equal between these two lines. Shift V, I'll add a dimension of 1 inch. And then I'm going to choose a symmetric relation from here to from this point to this axis to this point, and that makes sure that we're nice and symmetric. So we only have 1 degree of freedom, the length here. Now I have an arc, and I have a 3-inch dimension, and my arc ends horizontal to at its tangent point. So I know that its endpoint here is going to be vertical with its center point. So I can make this line 3 inches. And I can add my arc, or I can just, make this center line vertical and dimension 3 inches off of here. Same thing. I have a call out here. Now this is, when I made this drawing, this is not how you call out a radius, but I had to do it in this case. For some reason, all of the lines, or all of these arcs came in as B-splines, highly unusual, and it didn't happen with other versions I've made of this part using Boolean operations. So I'm not sure why that happened, but this is kind of a funky thing that denotes radius because I wasn't actually allowed to add a radius the way you should with the program. So this is going to be 6 radii that are each 1/2 inch. So we're going to say Shift R 1/2 inch. Next I can add in a line. We'll say T for tangent. We'll add a tangent relation in. And now I have a 65-degree angle. So I can say A for angle here. And of course, so I know that if I dimension off the center line, this would actually be 65 divided by 2. And so I can say 180 minus 65 divided by 2. And that gives me the angle that I want, 147.5 degrees. Easy peasy. We'll grab an arc. We're going to say T for tangent. We'll say E for equal, V for vertical. And now I can give this an overall dimension of 9.75 inches. So we'll say Shift H for a horizontal dimension, 9.75. And then I know that this is 4 inches tall, so I can dimension off the center, say 2 inches. And then if you're tired of adding fillets, you can also, let's add in a parallel rather relation there. We'll grab a fillet, and you can also add an arc that way. It's nice because it adds the tangent relations as well. We'll go with equal. Shift V for vertical. We'll get 0.5 inches there per the drawing. And then we need to add a thickness. It looks like 1/2 inch thickness there. So I'm going to go to construction geometry. I'm going to add a construction line that is coincident to this line. We'll make sure that these are perpendicular. And we'll give this a dimension of 0.5. So we have 1 degree of freedom. That's of course the length of this line. Let's go back to driving geometry. I'm going to add in an arc. We'll make it tangent. We'll make its center point to its end point horizontal, and that way we know we're vertical, tangent to vertical. And then it looks like we have a 1/4 inch radius, right? So Shift R. There we go, Shift R 0.25. Now, there's a few ways we can deal with the rest of our sketch. We can highlight everything and highlight this x-axis, and then I can choose a button up here, right here actually. It says creates symmetric geometry with respect to the last selected line or point. The last thing I clicked was the x-axis. So if I click that, I can mirror this across. Now this has no constraints or relations, so it is an option to just add in your constraints and relations. I rarely do that because I'm a control freak that likes to make sure that everything has the design intent that I want to right off the bat. So it goes pretty quick. We'll add an arc, we'll make it vertical, we'll add an equal relation here. We'll add, and we can add a tangent relation or just merge the center points, either way. We'll add another line, and we can merge these points. We'll go equal, and I think we still need a tangent. Yep, we're fully defined there. We'll add in yet another arc. We'll go equal, we'll go vertical, we'll go tangent, and fully defined again. We'll add in another line that I'm going to make equal, and then we'll add in yet another vertical line that we will make equal with this one. Maybe I'll select a polyline over here, right? And then I can choose my sketch fillets. Always fun to add. Select these guys, equal. Looks like we have an over constraint, so we'll Control Z, and I'll just do this one at a time. Equal looks good. Equal. Perfect. Next, I'm going to choose a vertical constraint from here to here. Vertical, and we are fully defined. So that wasn't too bad. Oh, and one other thing is we'll have a zero thickness back here, right? So I extended the front end. I should extend the back end as well. Now, if you don't want to lose your constraints and relations, then you can just flip this over to construction geometry, or you can do what I'm about to do and just say 11, right? Or whatever dimension. Doesn't really matter. In fact, I think that's a lot easier. But there are some cases where it's even easier if you want to not lose anything to make this construction and then build in whatever other changes that you want. But that should be our part. So let's close that. Now is the fun part, right? So I have two bodies, and this one is a little bit more bold in text than this one. That means that this is my active body. I can make this body active by double-clicking on it, and you can see this becomes bold and this becomes not bold. So with this activated, I can highlight my sketch, create a little extrude feature, and then we'll say symmetric to plane 4.5. We'll close that. I'll highlight my next body by double-clicking, highlight my sketch, extrude, symmetric to plane, and that's enough just to know that they intersect each other fully, right? That's what we want. So we've created two separate bodies that intersect each other, and we can use a boolean operation to make these into one. I choose this boolean over here. I click Add Body, and I select the only other body showing. It doesn't really matter which one. And then I choose Common. And that's saying where these bodies intersect, we're going to make the part. Where there's a body that doesn't intersect, we're going to remove that, right? So this is the part that is left when you take away everything that isn't intersecting with another body. We'll say OK. And now we can add some fillets. I think we have a note down here. All edges except the keyway to have an 1/8 inch fillet. So I'll grab my fillet tool here. Of course I have to select an edge first. And we'll give this 0.125 or an 1/8 inch. We'll add an edge. Maybe we'll do this inside edge. We'll add another edge here and another edge down here and another edge over here. And then I can check maybe this face for both of those edges and this face here. And we have successfully made our part. So I'll save this off, and now maybe I can show you a little bit why it is so important to avoid zero thickness, and especially if you're new at modeling. Zero thickness may be kind of a mystery. I'm going to delete my fillet, I'm going to delete my boolean, and now I have my two bodies intersecting each other. And if I go to my body and I highlight my pad, this sketch here, and I take this down to 1 inch as the drawing would have said, and I take this down to 9.75 inches, right? Now we have that little line there is a point where these two bodies intersect, and that creates zero thickness. So here I have an equivalent part that I've made that has those tangents like I've mentioned, and of course I have to have an active body, so I'll double click on one. I'll add a body here, right? Do the exact same that we've done before, and we get the same product. Now if I hide my sketch, does the zero thickness make a difference or not? If I go to add a fillet, this part immediately disappears and I get failed to create fillet, right? So being conscientious of zero thickness really pays off, because here we failed to create a fillet when it went right on, relatively large, on the other part that we've done that didn't have zero thickness. So be conscientious of any time you have a zero thickness error, because it might work, but then features later down the road, like adding fillets or maybe even references, may have some problems, as we see here. So this is our final video version. I will have this drawing and this part available to download if you would like on my GrabCAD, links in the description. I hope this video was helpful. If it was, please subscribe. I'll see you in the next one.